Yeah, might be you have tried to solve a few of the questions. Yeah, so that you will be you are getting ideas on the problems related to this Fourier series. So basically, tutorial 2 and 3 are covering the topics that we have learned in chapter 2. Okay, and for your information, we have finished chapter 2 yesterday. Okay, and we're going to start our lectures on chapter 3 next week. Okay, so this is the tutorial number 2. Yeah, it is only one page, and the topics covered for this tutorial 2 is on spectrum of signal and also a type of Fourier series. Okay, so as usual, I want to have a feedback from the students. Which questions that you think need guidance for me to solve it for you? All right. Any questions on tutorial number 2? So we have 1, 2, 3, 4 questions basically. So if we look at these questions carefully, number 1 is on the type of Fourier series. Okay, so we want you to actually convert all of these series A, B, C, and D into a cosine terms only. Yeah, cosine terms only, and then you must be able to sketch the spectrum of one-sided. Okay, and afterwards, we want you to transform from trigonometric cosine to a complex exponential for a series, and then you must be able to sketch a two-sided spectrum based on the results that you have obtained. Okay, so that is the aim, the purpose of question 1, which is to test you on this understanding. Okay, which part that you think that you need my guidance on this question number 1? Can you solve it all of them on your own?
Doctor, can you do the
Okay,
last one?
so the last one, question 4, is it?
Yes, question 4.
Question 4, let me see. Okay, question 4. Okay, can we do it step by step then? I think I need to have a feedback from the students on question 1 first. So is there any query on question 1?
Maybe the last one in question 1, D, because it's have everything from each one.
Okay, if you base on this question number 1, sorry, 1D, yeah, as mentioned by your friend just now, Faisal, right? Your name?
Yes, doctor.
Okay, Faisal. Okay, so we have based on these questions, we have 3 frequencies components. Yeah, frequency components. We have 50 pi, the first one. Second one is 100 pi, and the third one is 200 pi. Okay, so if we base on this, we have distinct component, distinct frequencies value. Okay, I think there should be no problem with the first and the second terms because it is in cosine terms straight away. But for the third terms, we have a 200 pi, which is in sine terms. So what we have to do is that we have to uh, change these sine terms into a cosine terms. Yeah, cosine terms in which we can use identity. Okay, so to change from sine to cosine, simply we have cos of 200 pi t minus pi over 2. Okay, minus pi supposedly, yeah. Okay, so this is based on these equations now. Yeah? Let me write it for you then. Okay. I'm going to use a Jamboard. Okay. So by right, for part D, I will concentrate on the third terms, yeah, which is have a sine term. So basically, we can say that let's say a cosine of theta, okay, shall be equals to sorry, I think it should be the other way around. Sorry, yeah, my mistake. Yeah? Okay, then. So we're going to have a sine of theta, supposedly. Okay, should be equals to cos of theta. Okay, minus pi divided by 2. Okay, so this will be the case now, yeah? So this is how you convert from a sine to cosine. Yeah, this is based on the identity. I believe that you have learned this, you have seen this identity before. So based on that, if we have the third term, which is 6 of sine, okay, so we have 200 pi t, right? 200 pi t minus pi over 2. Okay, so supposedly this will be just simply, you substitute all of this into these terms here. So we're going to have 6 of cosine. Okay, so that should be substituted here, this equation. So we are supposed to get 200 pi t, okay, minus pi, supposedly. Okay, so that's how we change from sine terms of this into a cosine terms, yeah? So once you have the third terms to be in cosine terms, straight away you can simply sketch the one-sided spectrum. Okay, and I think for the two-sided, which is to be based on the complex exponential, transformation from trigonometric cosine to complex exponential, I believe that it won't be a big problem to you. Okay, so that should be the first part, 1D. Okay, and any question for that? I hope that you're clear about these solutions here for 1D. Any question for part 1? I mean question 1? No? Okay, maybe it's too easy for you, yeah? Okay, question 2. Is there any query? Any question for question 2? Question 2, please. Is there any query?
Doctor, can we do it? Because even if we solve it, we cannot know if it's accurate or no.
For which one? Question 2, is it?
For question 2, yes.
Okay. You have not tried it before the class?
No, we did a different one in the class. We did the, I think uh, the first one in the table, the square
Okay.
wave.
All right. So let's have a look at this question 2. I think I have a solution for this. Yeah, I did this yesterday, just for the sake of assist the students in case if you have not done it before this session. Yeah. Okay. So this is the solutions to. I just select question 1B. Sorry for that. Yeah. This is for 1B. Maybe after this, I'm going to share these solutions for you, so you can learn this on your own later on. Yeah. Okay. This is for solution number 2. Okay. Where we have this is the sort of general functions with the amplitude of 6 and a period of 1. And as what we have learned in class, what you have to do is you need to, because if you based on the questions, yeah, question 2 here, the question is to determine the general form of exponential Fourier series of xt. Okay, so it is an exponential Fourier series, yeah. So basically, table B3 will give us the Fourier coefficients for exponential type of Fourier series. Okay, so straight away from table B3, we need to choose which signal do mimic or similar to this xt. So apparently this signal number 2. So for signal number 2, we managed to get that the C naught will be x naught over 2. That should be C naught, yeah? The coefficient, and the Cn is j x naught over 2 n pi. And from the figure here, we can extract the information that the amplitude is 6 or x naught is 6. and the period t equals to 1. So these two parameters will be usable later on when we write the full versions of the Fourier series equation. So this is the equation for the Fourier series in general for complex exponential. So we have d c naught plus summation n from negative infinite to positive infinite of Cn e j n omega t with n not equals to 0. Yeah. Okay. So by substituting the c naught and Cn into this equation, so we are getting this. Yeah, we are getting these terms, and then by substituting the x naught and t into the equation, so end up we're going to have these equations. So this is the general form, yeah, general form of exponential Fourier series for the xt, where this is your c naught and the rest is the Cn extended from negative infinite to positive infinite. Okay, so that's all for the solution for question number 2. Straightforward, basically. So as what I mentioned in class, you have to understand, you have to know how to extract the Fourier coefficients from the table B3. Okay. Right. So I think that you understand now, yeah, hopefully. Okay, for question 3, it should be similar to question 2, so I won't be explaining about this question 3, so maybe you can learn this on your own later on. But I have not do a solution for question 4 as asked by what was the name just now? Abdul Rahman Alatas just now. So I didn't prepare the solution for question 4, so I'm going to do the solution for this question 4 using the Jamboard. Okay, sorry. Okay,
Doctor, you gave us a link,
a link for
a
what?
chat for jam file.
Yeah, if we can look based on this,
Yeah,
yeah.
but you cannot access it.
Oh, you can access it, is it?
Yeah.
But never mind, because we're going to record. I'm going to record this, so you can just view it
Okay.
on the video, right? In the video.
Okay.
Okay, never mind. So I'm going to have a look at question 4 now. Okay, for the rest of students, no questions, yeah, for part question 1, 2, and 3. Wow, this class is very good, yeah. Students are very good. There are no questions on tutorial, so very good. Okay. Okay, about the question 4, we are given the spectrum, which is a one-sided spectrum. All right. So I think there's nothing much to be worried here. Yeah. We have the spectrum for the both amplitude and phase. So I just write the equation for the Fourier series based on the spectrum straight away. Yeah. So basically from this spectrum, I'm going to have yt. You can refer to the question. Yeah. Yt will be equals to 5, which is a DC value. Okay. Plus 3 is the amplitude, and cosine, because one-sided, yeah, so it should be in cosine terms. So the frequency is pi over 3, so we're going to have pi over 3 t, okay, and the phase is positive pi over 3, okay, so that should be your phase for that frequency, pi over 3, plus there is a 2 pi over 3 frequencies, so we're going to have a cosine, because the amplitude is 1, okay, so that should be 2 pi over 3t, okay, and apparently the phase is negative pi over 2 for this frequencies component. Okay, so that should be the equation for trigonometric Fourier series, which is part 2. Okay, right, and exponential, I think you can just expand it from this cosine by using the Euler's relationship. Okay, that's all for question 4. Right, nothing much basically. Yeah, nothing much. Just to make sure that you understand about the spectrum, yeah, how to write the equation, the Fourier equation based on the spectrums given. That's all.
So,
Okay.
Doctor, which one is I and which one is I2? Because it's like the question asks the exponent of Fourier series for yt and the trigonometric Fourier series for yt.
Okay, so what we have here is the trigonometric Fourier series of YT.
Yes, this is I2.
Trigonometric, yeah?
Uh,
This is trigonometric. So part one, so you have to do it on your own. Just convert the cosine into a complex exponential. That's all. Okay?
That's it. Okay. Thank you, Doctor.
All right, welcome. Okay, guys, no more questions, yeah? Too simple, yeah? It's too simple for you, I believe. Sorry for not able to develop harder questions for you. So maybe next time. Yeah. Okay. So if there's no question for tutorial number 2, I'm going to proceed now with tutorial number 3. Yeah, tutorial number 3. Okay, which is on the Parsons theorem and application of Fourier series, which have been learned yesterday. Right. So any questions? So we have 3 questions altogether. So is there any questions on this tutorial number 3? I'm waiting for your feedback. Okay, Abdurrahman Al-Hakimi, question 2. Let's have a look at question 2 as requested by Abdurrahman. Is it the B or question 2 of this? Which one then? 1B or question 2 here? Which one?
Assalamu alaikum, Doctor. Question 2.
Waalaikumsalam warahmatullah. Question 2. Is it this one?
Yeah.
All right.
Thank
All
you.
right. So, okay, welcome. So there should be no issue with this, yeah? Hopefully you can do it. Okay, for question 2, we are given this Xt. Yeah, Xt is a, I can say this is a modulus of sine t. That's what we have learned yesterday, right? Modulus of sine t, in which all of the amplitude is at positive side, yeah, positive side, yeah. And then the sinus of Xt is said to be added with the sine pi t, as normal sine function. And this addition will give us yt, okay. And yt is then said to be excited or passed through a capacitor of 0.2 farad. And this will result on the output of Zt. Okay, this is what given by the questions in this question 2. Okay, so the question number 1 or 2a is to sketch the yt in time domain. Okay, so you need to find out what's the yt, which is based on the addition of this xt and this sine pi t. Okay, so first thing first is that you need to first sketch the, okay, xt is given. Your task is to sketch the sine pi t now. Yeah, sine pi t should be having amplitude of 1, in which the sine function shall be fluctuated, yeah, or change from -1 to +1. That should be the amplitude for sine pi t. Whereas the period for this sine pi t should be equals to 2, yeah. Period should be equals to 2 because omega is pi. Omega equals to pi. So when omega equals to pi, from omega equals to 2 pi over t, you're going to have t equals to 2. So the period for this sine pi t should be equals to 2. So sketch the sine pi t. You sketch it first. Okay, and afterwards you have to add with the xt to give us the yt. Okay, so that is in general the solution for this yt. Okay, let's have a look at the solutions because I did it beforehand. Okay, this is solution for question 1. Maybe you can refer to this later on. Yeah, I spent my time yesterday night just to do these solutions for you. Okay, hopefully you can find you find it useful for your use later on, yeah, just to prepare for your test or final examination.
Doctor, can you explain question number 3?
Number 3. Which question number 3? No, we are now dealing with question 2.
No, because when you scroll down there was Q3, so I thought it's question 3. Sorry.
Yes, question 2 now. Yeah, it's question 2. Okay then. This is solution for question 2. We have the xt here. And this is your sine pi t, which is drawn in the red color line here. Okay, so we add them together. So if we compare, the Xt is having a period of 1. So 1, 2, 3, but the sine pi t is having a period of 2. Okay, so if we add this together based on what we have done in chapter 1 on the sinus operation, we can see that addition between these two functions will result in the addition between 0 to 1, 2 to 3, yeah, and further on from 1 to 2, -1 to -2, yeah, that should be addition. But interestingly, there will be a cancellation of signals. For example, from 1 to 2, yeah, because from 1 to 2, the peak is at 1, but for the sine pi t, the peak is at -1. So when we add this together, those two signals will be cancelled out. The same things apply for signals between 0 and -1. Yes, 0 and -1, there should be a cancellation. Okay, but remember, from 0 to 1 and 2 to 3, for example, and also for -1 to -2, both are having same amplitude, 1. So when we add this together, we're going to have the new amplitude of 2. So as a result, your yt should be looked like this. Okay, in which there should be part of the signals which are added and part of the signals which are said to be cancelled out. Okay, so that should be your yt signals. Okay, so hopefully this you understand about the solutions on the addition and the cancellation of the signals, both xt and sine pi t. Okay, hopefully okay, yeah. Right now, part B is to write the complex exponential Fourier series of xt, yt, and zt up to the third harmonics. Okay, so if we base on this xt clearly, xt and also the yt, yeah, xt and yt is here. So basically, you can find these two signals in table B3. In table B3, yeah, in table B3, if I can refer to table B3, this is the one. Okay, so you can see that the signals are actually similar to question 4, full wave rectified, and also signals number 5, which is half wave rectified. Yeah, so these 4 and 5 signals shall be used, yeah, shall be used in extracting its Fourier coefficients here. Yeah, and that should be used in the solution to find the Fourier series for xt and yt. Okay, for the zt here, you need to apply the application of Fourier series that we have done yesterday when we have a 0.2 farad capacitor. Yeah, 0.2 farad capacitor in this circuit. Yeah, in this circuit. Okay then, so let's have a look at this xt because I have not solved everything for you. I think I just solved for the xt. Let me see. I think I just solved for the xt because I believe that for yt and zt you can solve this on your own. Yeah. Yeah, this is the xt, which is we are now referring to signal number 4 in table B3. And if we base on this xt function, the x0 is 1 and the period is 1. Okay, so we are having this, and this is your Fourier coefficients extracted from the table. And if we base on the questions, it requires us up to third harmonics. Up to third harmonics means that the n shall be starting from -3, -2 up to +3. So that's why I prepared earlier these coefficients of Fourier. We have C0, C-1 up to C-3. So that should be the coefficients of the Fourier that is extracted from table B3. And subsequently, we can simply write the xt, which is a exponential Fourier series. Okay, so we have 2 over pi C0, and the rest is the, for example, here is for C-3. Yeah, so C-3 we have -2 over 335 pi exponential -j 6 pi t, because the omega equals to 2 pi. Yeah, 2 pi. So n of omega t will be 3 times 2 pi with 6 pi lah. So that will follow the rest of this xt. components. Yeah. Okay. Right. So that should be your Xt. So YT, I did mention here. Please refer to scene number 5. Yeah. So please try on your own the same method that I put in this slide. Okay then. Hopefully you are clear about the solutions on question number 2. Okay. Abdul Rahman Al-Hakimi, is it clear? Your questions on question 2?
Yes, Doctor. Thank you.
Welcome. Thank you very much. Okay, so for the rest of students, is there anything that I can help you on tutorial number 3?
Question
yes,
3, Doctor.
Come again? Question 3 here, is it?
I have a
Yeah.
question in question 2.
Question 2, this one?
Yeah, how do you get that? Is it current voltage? What's going on?
Current
Z
voltage.
of t.
Let me see. Come again, your question is?
How do we get Z of t?
Z of t, okay. So basically you have the YT. Okay, you have the YT. So you can simply find the ZT based on this 0.2 farad. Okay, and I believe that for this particular case, we're not given any information, yeah, whether the YT is it a voltage or current. So what we can do in this particular case, I think we mean something here. YT supposedly will be a current, so ZT will be the voltage. Yeah, so YT will be the current and ZT will be the voltage. So basically from that equation, I mean from what we have done yesterday, we can use the Jamboard now. Okay. Okay, so from that, let me see the questions. Okay, so basically, you have the YT, which is the input to 0.2 farad, the capacitor. Okay, that's a YT. Okay, the YT is there. And that should be your output, which is ZT. Okay, and the capacitor is 0.2 farad, right? So basically, what we can do from the equations that we have seen yesterday, yeah. So we have VT, okay, based on the impedance equation, yeah, for this capacitor. We have IT. Sorry, I need to use the ZT lah. So it clear. Sorry for that. Okay, your ZT here, which is the voltage, will be equals to the current, which is YT. Okay, multiply with this capacitance, which is equals to XC, or I can simply use 1 over J omega C. That should be the case lah. Okay, J omega C. Okay, so since we have omega, sorry, since we have C is 0.2 farad, so we're going to have equals to YT, okay, multiply by 5 over J omega, okay, or simply you can have it as in a phasor form. You can have YT, okay, of 5 over omega, okay, with the angle of negative 90 degrees or negative pi over 2 lah, yeah. Okay. So the YT is what based on what we have obtained previously. Okay, so by this you must be able to find the ZT based on the component of the frequency. So what we have, this is based on what you have learned yesterday, in which you have to find out what are the ZT components. Yeah, so depends on how many frequencies that we have in the YT. Okay, so okay, is that clear on this?
Yes, doctor.
Okay, thank you very much. Yeah. Okay, Kai Sheng Tan, you are asking for question 2C. Let me see. Question 2C. 2C, is it on sketching the spectrum? Tan Kai Sheng? I think for Because once you have the expression of complex exponential terms, okay, you must be able to sketch the spectrum, right? For double-sided, am I right? So it won't be an issue now, hopefully. Let me refer back to this to the solutions of tutorial 3. Okay, let me see. Yeah, this is the solution for tutorial number 3. Okay then. So if based on the solutions here, okay, you have actually few components. Okay, you have 2 over pi, and these are the components. Yeah. Okay. So based on this given or obtained xt, basically you must be able to sketch the spectrum straight away. Yeah. So let's have a look then. Never mind, I'm going to do this for you. You have 3 frequencies component on the left, and also 3 frequencies component on the right, negative 6 pi, negative 4 pi, and negative 2 pi, with the amplitude of negative. Okay, one more thing to remember here, that in the spectrum, amplitude spectrum, we try not to put negative as the amplitude. We always take the amplitude to be a positive. So this negative sign shall be regarded as a phase. Yeah, as a phase, in which we have learned in our lectures before, that -1 is equals to a phase of pi, or negative pi. Okay, am I right? So basically, these equations here, or these terms here, I take one example here, right? This can also be written as 2 over 35 pi exponential of negative j 6 pi t exponential of j pi. So for this particular case, this particular term, the amplitude is 2 over 35 pi, and the phase angle for this term is, or for this frequency 6 pi, is pi. Okay, so you got the point there. Yeah? So in terms of the Jamboard, in terms of the sketching for this example, let me the window. Okay, let me see here. Yeah? Right. So, for instance, we have this is your double set spectrum. Is omega. That's your amplitude. Okay, that's your amplitude. So we have 3 components. Let's say this is what? Yeah, this is 6 pi, for instance. Yeah, if I recall back, 6 pi. We have 4 pi on the right hand side. Yeah, and here we have 2 pi. Okay, and the same things apply for the left. Negative 2 pi, negative 4 pi, and negative 6 pi. Yeah? Okay, that should be the case. Okay, negative 4 pi. And this is negative 6 pi. Okay, so if we can recall back the things that I've shown you just now, for the 6 pi, the amplitude should be equals to 2 over 35 pi. Okay, supposedly, and the same things applied for negative 6 pi. You are getting the same amplitude value, which is 2 over 35 pi. Okay, and for this negative 4 pi, if not mistaken, you can refer to the equation back. It should be 2 over 15 pi, yeah, because I cancel out. I mean, I ignore the negative sign, because negative sign will be taken to the face. Yeah, taken to the face. So that should be 2 over 15 pi. Okay. Sorry, hopefully you can see my handwriting. Okay, and for this, oh, sorry. Very bad. Okay. I think for this, I'm not sure what's I think it should be 3 pi lah. So it should be 3 pi, yeah? 2 over 3 pi. And the same things applied for positive 2 pi. Frequency is going to have 2 over 3 pi. Okay, that should be the case. Okay, about the phase, this should be the amplitude spectrum, yeah? And for the phase spectrum, okay, phase spectrum, again, we have, sorry, I'm going to use this next screen here. So for the phase spectrum, there should be a phase spectrum, omega. Okay, that should be the angle, yeah? This should be the phase angle of x, t. Okay, so you have, again, there are 3 component of frequencies, 2 pi, 4 pi. Basically, I don't have a solution for this, yeah? Sorry, I don't have a solution for 2c, so I have to do it here. Okay, that should be negative for 2 pi. That should be negative for 4 pi. Okay, and then you have a negative of 6 pi. Sorry. Okay, so if based on this, let's have a look, yeah, on the question just now. If we can share back this. Okay. So if you base on this, if you look at these particular equations clearly, you can see that the all of these will be having a phase of negative pi, yeah? Negative pi or positive pi, because positive and negative pi, the value will be the same. Okay, so it doesn't matter whether you put it as a pi or you put it as a negative pi, because there should be no difference, yeah? Right, so the same things apply for all of these terms, yeah? For the second terms, third, fourth, fifth, sixth, and seventh, all of them will be having a pi or negative pi as the phase because of this cancellation of negative sign for the amplitude. Okay, hopefully you are clear about the solutions. So for that particular case, if we go back to this Jamboard, okay, so you are supposed to get, sorry, yeah, so all of these will be a pi, yeah, I take pi as this value instead of negative pi. Doesn't matter, if you put negative pi, that should be okay, there should be no wrong with that. So the amplitude for the phase, I mean the value for the phase will be fine for all of these 6 lines spectrum. Okay, so that should be the solution for the phase spectrum, yeah? Tan Kai Sheng, hopefully you understand this, yeah? Okay, there's a query from Ling Jing Kai. YT is partial capacitor. So I believe that from that idea, YT basically is a voltage. Sorry for that, yeah, Ling Kai. It should be YT is a voltage, supposedly. It's not a current. YT is a voltage. Thank you very much. Yeah, it should be voltage.
Doctor, is it current or voltage? Because in the previous example, you solved it as the YT is a current and ZT is voltage.
So I make a correction here that YT is a voltage basically.
YT is a voltage.
Yeah,
Okay.
YT is a voltage. So please note at my
So
chat
ZT
here,
is a
current. ZT is a
current.
current.
Okay.
Thank you, thank you, Jin Kai and Kai Sheng. Thank you very much. Okay, guys. Hopefully you understand. Yeah, solution for question 2 and the solutions of it. Basically, in the questions, you will be given whether, for example, say question 2 just now, YT, whether it's a voltage or current. Basically, it will be given. Yeah, whether it's a voltage or current. Okay, there's no such thing that we need to predict whether YT is a voltage or current. Yeah. Yeah, I think I missed something here on these questions. Part of the questions, I missed it, the information of the questions. Okay, question 3. I think question 3 is what we have done yesterday. Yeah. So shall we proceed with question 3, or you can do it on your own, because the ideas will be same as what we did yesterday. It's a series circuit of R and L. So I think same like what we have yesterday. Yeah? So I don't think we have to proceed with question 3. You can try to solve this on your own, yeah? Is it okay? Okay, good. That's a reply from Abdul Rahman. The atas. Thank you very much, Abdul Rahman. So, but still, if you find any difficulties for tutorial questions 2 or 3, you can always ask me through WhatsApp, yeah? PM me, just PM me for explanation. Okay then, I think that's all for our tutorial session for today, because I found out that not much question posted by the students, and I believe that all of you, or most of you, have understand chapter 2 very well. Yeah, chapter 2 very well. Yeah. Okay, good to hear that. Yeah, I hope that you do understand chapter 2 clearly on, yeah. For next week's lecture, inshallah, we're going to proceed with chapter 3, yeah? Chapter 3, which is on Fourier transform, as what I've mentioned yesterday. And again, I want to remind you that next week, we are going to have a second quiz, okay? Second quiz, which is on Fourier series, okay? Next week. I'm not actually decided yet whether to do it on Sunday or Monday. So just prepare yourself for the quiz next week on Fourier series, chapter 2. Okay, so I think we are now ready for quiz 1, yeah? Yeah, we're now ready for quiz 1. So I'm going to post questions here using the Google Meet screen. And for the submission of quiz 1, the answer, you have to submit it using the Google Classroom. Yeah, Google Classroom. I'm going to put a link, yeah, on the classwork, on the Google Classroom, so you can submit your answer in the Google Classroom. Okay then, so can we proceed now with the quiz 1? Okay, yeah, so hopefully you are now ready to sit for quiz 1. So let me share this, the quiz, the questions now, yeah. Okay, so I think you can see quiz 1 clearly. Okay, so this is a question for quiz 1. So we have part 1, 2, and 3 for this quiz 1. So you can straight away answer the questions, and please submit the questions, submit your answer before 12:15. Yeah, so you are given a very plenty time, more than 20 minutes. Yeah, more than 20 minutes to solve this question number 1. Okay, is that clear? Okay, yeah, so I think you can proceed with this answer. Try to answer the quiz 1 straight away, yeah?